In this example, we're having a look at differentiation with quotient rule. Actually, I think this one's quite a hard question because it works out being quotient rule within a quotient rule, if you can believe that. It's a bit of a nightmarish sounding thing, isn't it? But you can break it down very easily if you are just systematic and just chunk away at it step by step. So let's have a look and see what I'm talking about with this quotient rule within a quotient rule, guys. So y equals, that's what I always start off with. I let y equal this if they're not using y notation up here, because I like that for the dy dx notation that follows. Okay, so alright, y is x over tan x. Now that's u over v, where u is x and v is tan x, and you can see that that's a quotient. It's sticking out a mile that that's a quotient, so we've got to deal with that. Now let's go ahead and find du dx and dv dx now. Du dx equals 1, which is very straightforward if u equals x. Now dv dx, that's not quite so straightforward at all, because tan x, you're not taught what the derivative of tan x is, although I teach my students to remember it anyway once they've worked it out. Basically it is sec squared x, where sec is 1 over cos. I really highly recommend that you remember that one. The derivative of tan is sec squared, where sec is 1 over cos. But let's work it out, assuming that you didn't know that, okay? And you got lumbered with this in an exam setting, and we'll just plug away and we'll work it out anyway. So v equals sine of x over cos of x, which is a quotient rule all by itself, isn't it? So to get dv dx, we've got to use quotient rule just for this particular bit, and then go back to our quotient rule up here, which is the main event, if you like. So, alright, we've got dv dx equals, now it's bottom d top, that's the derivative of sine is cos, minus top d bottom, and the derivative of the bottom, which is cos x, is minus sine x over bottom squared. Okay, that's my way of doing quotient rule. Bottom d top minus top d bottom over bottom squared. Okay, hope you can decipher what I'm talking about. Now we've got to work this out now and simplify it in the next line. So we'll get cos squared x plus sine squared x. Well, golly gee, that equals 1, guys, over cos squared x. I hope you knew that. Cos squared x plus sine squared x equals 1. If you didn't know that one, you better remember that one, and remember it very, very well. It is vitally important that you know that. So that's 1 over cos squared x. Alright, well now we've got our dv dx. Okay, so now we've got du dx, dv dx, and we can go back into this beast and work it out, okay? So by the quotient rule, dy dx equals, in this expression up here, in this equation up here I should say, it's bottom d top minus top d bottom over bottom squared. Now we can just plug and chug now, but it is getting complicated. So there's bottom, there's d top, heavens, minus top d bottom, is that right? Oh yes, that's the derivative of tan, which is sec squared, or 1 over cos squared, over bottom squared. Now guys, from this point here, we're trying to find out, reread the question, we're trying to find f dashed of x when x is pi on 3. So look, please don't try and simplify that anymore. You're just going to get yourself into a great big mess. Just plug and chug for the actual values of these trig functions when x is pi on 3, and I think you'll work it out a lot more easily. So, tan of pi on 3 is root 3, I hope you know that. Cos of pi on 3 is a half, and that'll be root 3 all squared, and that term there is a pi on 3. So let's just work it out now, and hopefully it'll come out easily for us. So we're substituting x as pi on 3, so what do we got now? Just check. That's root 3 times 1 minus pi on 3 times 1 over a half all squared. That's correct. Over root 3 all squared. Good heavens above, be careful. We'll just have to simplify that now in the next line. So what have I done? I've said that term is root 3, that's all right. Now, that little beastie there becomes a quarter, and if you're dividing by a quarter, that becomes 4 when you flip it. So that's 4 pi over 3, and root 3 all squared is 3. Goodness, that worked out really well, didn't it? Okay, so, now, should we fiddle with that anymore? Should we? Well, basically, what I've done there is just prettied it up a tiny weeny little bit by making the putting this 3 into that term there, so that the whole numerator was over 3, and then the 3 comes down here to be times this 3, which gets us 9. And that's my answer. But look guys, this answer here is perfectly acceptable, and in many ways I would discourage you from making that transition from that step down to there, because if you mess something up and you get it wrong, that's a tragedy, because you would have had it right up to this point. Alright, so just be very careful and don't engage with it too much. Maybe I've made a mistake doing that, but I was confident in doing it, and I thought it didn't take me very much more time, so I just made a value judgment and did that. But don't go prettying things up too much. That would be perfectly acceptable. Alright, we'll see you next time. Thanks for being with me.